Okay, so now we will start the workup for our SN2 reaction, and for that I have already taken 2 ml DI water here. This is the 2 ml saturated sodium bicarb, and this is the 2 ml of saturated sodium chloride, which is brine for our washing, and this is the clean and dry test tube. So what we will do, we will separate the upper layer. I left this a little longer so I can see it start getting crystal. So what you have to do, I will show you once again. So go with your rubber bulb and press before entering. Go to touch the surface and slowly suck the upper layer only. Remove it and transfer into new vial. Once again, press the rubber bulb, go inside the liquid. Do not go all the way to touch the second liquid. And then here you can see, I left everything almost, did not touch any acid. So here we have sulfuric acid water. So this is have a higher density, that is why it's bottom, and this is our product which have the lower density, so we were on the top. Now it's washing time. So we'll add first, this is the DI water. So add DI water and mix it. Once we'll mix it, and then after mixing, this bromobutane have higher density than water. So bromobutane will go at the bottom, your water. So I mix and wait for a couple of minutes, and now here you can see this is the water layer at the bottom and my oil or product is on the top. So I will remove it from here, press the bulb and then go slow and then collect from the top. So this is my product, bromobutane. Very carefully you have to collect, and we can throw this as in the waste, and then we will wash with the sodium bicarb. So okay, so now it's time to add saturated sodium bicarb solution, 2 ml. So here you can see, once you will add sodium bicarb and mix it, again your product will be on the top because we have a small layer on the top, and we added more 2 ml sodium bicarb at the bottom. So you can again mix and wait for a couple minutes to separate all the product, and then we will separate. So this is the after sodium bicarb wash. So upper layer is our product, which is small, and the lower layer is our sodium bicarb. So here very gently we have to remove from the top layer, and this time I am adding directly into the sodium chloride saturated solution so that we can dry it. One more time, it's a very small oil, is still there, not too much left. So you have to label your vials, make sure what you have, otherwise you will be confused. And then mix again. So mix again and wait for a couple of minutes to separate the two layers. So now you can see this is the sodium chloride wash. It has separated two layers are separately. Now we'll transfer into take two test tube, dry and clean. Here 1 and 2. One is for to dry the product over calcium chloride and another test tube to take the mass. So I will slowly and very gently will move the upper layer into this test tube and will measure. Here you can see nothing is there. So next is to dry our compound. Now I would like to show you an alternate workup to in the same test tube, how you can do that. So here you can see this is our test tube where our product is on the top layer and the DI water is at the bottom. So we have to keep the product and remove the water. So what you can do, go all the way inside and start sucking only water. Leave the oil in the test tube. Throw this water layer, go all the way in pipette and remove very slowly water only. Next we will do sodium bicarb wash. Now in the next washing in the alternate workup, here you can see I wash with the saturated sodium bicarb solution, and still in this vial you can see some air bubbles are going, so it means there will be some acid which is neutralizing. So what I will do here, I will keep the product in the same vial, and remove the sodium bicarb wash from the bottom. So go all the way in through pipette. First press this rubber bulb and then go all the way in the bottom and suck the only bottom layer. Throw in this waste. Once again press this button, press this bulb, go all the way in the bottom and remove the only bottom layer. Once again a small amount, very small amount remain. That's it. Next we will dry our solution with the sodium chloride solution. And lastly, here in the alternate workup, in one vial keep the product on the same vial, and I have washed this with the saturated sodium chloride solution. So we have to remove this from the bottom and then keep this product in the same vial, which is bromobutane. So press this bulb first and then go all the way inside. Slowly suck the solution from the bottom and throw it in this waste container. Once again press the bulb, go all the way inside and slowly remove all the last drop. And here you will have better yield than the previous workup. So alternative workup will give you less cleaning tube and better yield.
So this is our product, and now we are going to dry it using calcium chloride. and all you need is about that much. And we're just going to put it into our product here and give it a good little mix.
Yeah, to dry the residual water, if any there.
And next we're going to weigh how much our product is. So we're going to start off by putting our clean test tube that we're going to transfer our product in along with this holder and tear that. And then I'm just going to transfer the liquid from this test tube to this one. And get as much as I can. Okay. And now weighing it.
So it's a 0.560 gram, which is good. Now we will test sodium iodide. In SN2 workup, identification and test of product 1-bromobutane. Sometime workup of SN2 reaction for 1-bromobutane product is confusing. To identify which layer is the product and which layer is aqueous washing, because the completion of reaction depend on the reaction condition, temperature, time and presence of acid, etc., and also on the density of the product and aqueous layer. So here is some important tip to identify and test of the product. Normally we are using more water than oily product, so you can think about that larger layer will be your aqueous washing or acid washing, and a small layer will be your product, number one. And number two, we are going to do a sodium iodide test for the 1-bromobutane. So for that sodium bromide test, we can take aqueous washing and 1-bromobutanol as a starting material and product of for 1-bromobutane, the product you obtain, and we can compare these tests with the pure 1-bromobutane. So let's do this sodium iodide test. So now we will do the sodium iodide test for our 1-bromobutane. See if we have this is our crude product which we obtain. So let's see if we have the correct bromobutane or not. So for that, here I have taken 4 test tube, 1, 2, 3, 4, and one of them I will add water as a negative control. Second one I will add 1-butanol, which is starting material, as a negative control. Third, we will add 1-bromobutane 5 drop, which is the positive control, and in the fourth one we will add our this crude product. So for that, here I have taken 1 ml each. This is the 15% sodium iodide in acetone. So let's add one drop each. One and 1. So in this way you can see I have added 1 dropper or around 1 ml each, and now I'm going to add 5 drops of water. So this will be 5 drops of water. 1, 2, 3, 4, 5, and keep the dropper separately, and then 1 butyl alcohol. So this is 1 butyl alcohol or 1-butanol, which is my starting material. 5 drops, 1, 2, 3, 4, 5, and then I will keep separate this. Next is I'm going to add my another positive control, which is the 1-bromobutane, which is the commercial sample. So 1 2 3 4 5. I'm going to add a little bit more because here you can see it is getting immediately precipitate. Let's add some more. Now you can see it's all white. Now it's time to test our sample. So here is this the crude product. This is the crude product, and we'll test with this one. So 1 2 3 4 5, and I'm seeing yellow color precipitate. Here you can see this. I'm going to add more. 1 2 3 4 5 6. So here you can see, if we'll mix this one compared to the 1 bromobutane, we got the precipitate, but this is the white and this is the yellow. So it means, what is the conclusion? That our product for 1 bromobutane is the crude and it requires further purification. So here you can see this is the test you can perform. This is the positive control, and this is the our crude product, which is still contaminated or it need further purification. So this was the common sodium iodide test for doing bromobutane tests. So here you can see in the water there is no precipitate. In 1 bromobutanol there is no precipitate, which is starting material. This is the commercial sample. It's a really white precipitate because I added a lot. Let's add all of these to this, and then probably it has a very small amount of the bromobutane and large impurities are there. So still we need to further purification for this product. So we got our product, but it need to for further purification. So here we can do one more test for the pure 1 bromobutane, that which is called density test, because water have a density around 1 gram per centimeter cube, and I have taken here around 5 ml water, and the pure bromobutane have density 1.27 gram per ml or per centimeter cube. So it should be in the bottom there. So let's check it. So here I'm taking this 5 ml water. This is the 5 ml water, and transferring into this vial. So here you can see it's a larger layer, very large. Let me change this view so that you can see. And next I'm going to add here, this is the pure 1 bromobutane. Let's add 1 drop and see. Now you can see where it is going. So once you will shake it, and now you can see this is the bottom layer. So that higher density of bromobutane will be at the bottom layer, and another water have lower density, so it will be on the top layer. So the top layer is water, and the lower layer is the 1 bromobutane. So pure bromobutane always goes in the bottom layer of the water. So this is the one more test you can perform if your product is pure or impure. This was the density test.